Hi, I'm Joseph from IT2102, and in today's video, I will answer all the activities here in Chapter 8, entitled Subnetting IP Networks. So, this chapter examines in detail the creation and assignment of IP network and subnet network addresses through the use of subnet mask. So now let's proceed to the activities. So, first activity is on first activity is on Chapter 8.1.4. So here it is. So activity, calculate the subnet mask. So it's already said it's basic. So instructions, in this activity you are given a subnet mask in decimal format. Enter the binary representation of the subnet mask in the octet field provided. Additionally, convert the mask to prefix notation format in the prefix notation field. So as you can see here, we will calculate the subnet mask. So we will calculate into binary. So we can apply our learnings from chapter 7 here. So subnet mask is 255.255.248, so that's 0. So let's let's start now. So let's start answering. So subnet mask in binary. So 255 has all the octets are 1, so 1, all octets are 1, 1 again. So here in 248, so the octets will not all be 1, so there will be, I think, 0, 1, 1, 1, 1, 2, 4, 8, so 7, 1, 2, 4, 2, 4, 3 zeros, 3 zeros, and this will be all 0. So the prefix notation, getting the prefix notation, you will just add up all the ones here. So 8, 16, 16, 17, 18, 19, 20, 21. So it's 21. Let's check it. Yeah, it's correct. So let's try again another number. So now the last subnet mask is not 0. So let's try that. So let's press reset. Again, it's 255 because the sum of the all octets are 255. So 255. Again 255, and this one is 248. So just like 3 zeros again. So let's count the one. So 8, 16, 24, 24 plus 5 is 29. So let's check it. Yeah, it's correct. So let's try again. So now the last subnet must is 0. So let's reset it. So it's 111 again, 111 again, 240. So 1111, so 4, 1, 2, 4, 8. Yes, so 0. So 8, 16, it's 20. So let's check. Yeah, it's correct. So that's all about activity. Calculate the subnet mask. So it's very basic. So you just get the octets here. So when the octet is not 255, so it means there will be 0. There will be 0. So but that's all the perfect notation, and let's proceed to the next activity. So the next activity is here. Activity, determine the number of bits to borrow. So instructions, in this activity you are given the number of hosts that are needed. Determine the subnet mask that would support the number of hosts as specified. Enter your answers in binary, decimal, and prefix notation format in the fields provided. So these are the hosts needed: subnet mask binary, subnet mask decimal, prefix notation. So in here, the host needed is 25. So we'll just put the 1, 1, 1, 1, 1, 1, 1. So in this scenario, so 25. So we will count. So 1 2 4 8 16 32 64 128. So it means 25 is so less than 32. So 1 2 3, so 32 64 128. So it means it's all zero. So 255 that 255 that 25. So you will compute. So 128 plus 64 plus 32, so 224. And the perfect notation is, you will count all the ones again, so 8 16 24, so it's 27. So in the next one, the host needed is 1000. So 1, so and then now, so 1 1 1 1 1. So this will be all zero. So this will be equal to 255. So 255. So 128 2. So 2 zeros are needed, and then 255.0. So it's all, and 8 16 1 2 3 4 6 22. So in this one, the host needed is 75. So 111 111. So in the octet, so 128 below 7, so 64. So it's only be 1 because 75 is greater than 64, so it will not, 64 will not be included, only 128. So 255 dot 255 dot 255 dot 128. So then it's 25. This one host needed is 10, so 1111 again, 1111 again, and this one the host needed is only 10, so 111. So 1 will not be included because it's low, it's less than 10. So again, so 1 2 4 1 2 4, so it's 7, so it's 8 1 2 4 8, and then 16. So 111, it's 240. Wait, 1 2 8 plus 64 plus 32 plus 16, so it's only 1, so 16. 16 is greater than 10, so it will be included. 16 is greater than 10, so it will be included. So 240, so 28. So the host needed is 500. So 111, 111, and 111, and 0. Because we will sum, because 128 is less than 500, so it will be 0 all, and then 258, I think. So it will be less than 500 again. So then 255 dot 255 dot 0. So that's 23. So yeah, let's check it. Yeah, it's all correct. So that's all the activity. That's all about the activity. Determine the number of bits to borrow. So it's just easy. You just determine the host needed. So and then if you are familiar to the octets, you will easily answer this part. And then Getting the subnet mask, you just sum up the octets here. So, and then the prefix notation, sum up all the ones here. So yeah, that's all about the activity. So now let's proceed to the next activity. So the next activity is on 8.1.5.8. So here it is. So activity part 1, practicing VLSM. So instructions: table 1 uses regular subnetting to accommodate the network shown. Table 2 uses VLSM to further subnet the network. Drag the addresses to the appropriate subnet description. So these are all the subnet. So 192.168.50. The prefix is 24. Table 1 per subnet's calculation. So calculate 50 users per subnet. So new subnet mask decimal. So it's 255. So first prefix notation. So we know that prefix notation is just like this. So first full subnet range. So first full subnet range is 192.168. So second full subnet range. So it's 127. And the last full subnet range. So it's 192. So let's check it. Yeah, it's all correct. So new subnet mask is 255.255.255.192. The first prefix notation is 26. First full subnet range is 192.168.5.0-192.168.5.63. The second full subnet range is 192.168.5.64-192.168.5.127, and the last full subnet range is 192.168.5.192.168.5.255. So yeah, that's all about the activity part 1, practicing VLSM. So now let's proceed to the next figure. Activity 2, practicing VLSM again. So instructions: table 2 uses VLSM to further subnet the network. Drag the addresses to appropriate subnet description. So these are the addresses. So use table 1's second full subnet range in VLSM to calculate for 20 users per subnet. So it's 20 users. So second full subnet range 26 from table 1. So it's 192.6. New VLSM subnet mask decimal. So it's decimal, so 255. So number 3 is VLSM prefix notation. So prefix notation. First full VLSM subnet range. So it's this one. Last full VLSM subnet range. So this one. Let's check it. Yeah, it's all correct. We have correctly calculated the subnet using VLSM. So yeah, that's all about activity part 2, practicing VLSM. So now let's proceed to the last activity here in chapter 8. So the last activity here is all about VLSM, or variable length subnet mask. So in here, as you can see, I have the number host. I will use this as a guide. So, and also the binary host. So this is my IP address. So you can use the IP address you want. So, and then this is the table: subnet mask, subnet address, subnet mask, first usable host, last usable host, and the broadcast address. So, and this is the PCs. So with their corresponding numbers. So 62, 28, 20, 10. So in the subnet 0, you will just type your IP address that you included. So 192.168.3.0. Yeah. So to get the subnet 1, so this is the PC1. So the subnet with number 62. We will we will get the highest number, higher number than 62. So it is 64. So so we will just add 64 to the to our IP address. So 192.168 that so 3.64. So so before we get the subnet 234, we will first get the broadcast address, last usable host, first usable host, subnet mask of this subnet 0. So to get that, we will subtract 1 from the subnet address 192.168.3.64 to the last digit. So it will be 192.168.3.63. So you can see it will be now 63. So in the last usable host, so to get this, you will subtract again from the broadcast address. So it will be 2.168.3.62. Now it's 62 because we subtract 1 from 63, so it's now 62. So to the first usable host, in order to get this, you will just add 1 to your original IP address. So it will be 192.168.3.1. So yeah, we'll just add 1 to the 0, so to the last digit. So to get the subnet mask, you will just you will just get it here to the binary host. So our number is 64, our magic number is 64. So in this, it has total of 24 no 24 subnet. So to get the subnet mask, so we will just count from here to 24, 25, 26. So our subnet mask is 26. Yeah, so now we will get the subnet address of subnet 2. So the subnet 2 is 28. So the 28, so the greater number than 28 is 32. So we will just add 64, we will just add 32 to the 64. So the answer will be 192.168.3. So 64 plus 32 is 96. So we will get the broadcast address of subnet 1. So in here we will just add 1 again. Minus 1 again. So 68.3.95, and then minus 1 again from the broadcast address 68.3.94, and then the first usable host, you will just add 1 here. So 168.3.65, and then to get the subnet mask, so we will just count here start from 24 to 25, 26, 27. So it's 27. And then next we will get the subnet 3. So subnet 3 is 20. So 20. So it means the greater than 20 is 32. So we will just add 32 to the 96. Then 96 plus 32 is 128. So 192.168.3.128, and then get the broadcast address. So it's only the process, so just do it and do it again. So 192.168.3.126 minus 1, so 127, and then minus 1 again here on the broadcast address 168.3.126, and then we will just add we will just add up here. So the subnet address here, so 192.163.97, then the subnet mask, so 32. So again, it's so this is the same as the subnet 2, so subnet subnet 1, sorry. So 24, 25, 26, 27, so it's 27 again. 27 again. So now let's get the subnet 4. So subnet 4 is 10, so the binary host, so 16 is greater than 10, so 16. 128 plus 16 is 144. 8.3.144. Get the broadcast address 2.168.3.1 to 143, and then -1 again from the broadcast address, so 192.168.3.142, then add 1 to that subnet address to the last digit, so 8.3.129, and then let's get the subnet mask, which is 10, so 16, so 24, 25, 26, 27, 28. The subnet mask now is 28. So in order to get subnet for just for formalization, so you just use again the last PC number 10. So PC number 10 is 16, so we will just add 192.168.3, so we will add again, so 16 to the subnet 4, so that what's now 160. So let's get this broadcast in order to complete the table. So broadcast, so 192.168.3.159, and then get the last usable host, so -1 to the broadcast address to the last digit, so 2.168.3.158, and then first usable host, just add 1 to the last digit of subnet address, subnet 4, so 192.168.3.145, and then last, let's get now the subnet mask, so it's 16, so it will be all will be the same as subnet 3, so it will be 28. And yeah, now we're done getting the subnet address, subnet mask, first usable host, last usable host, and broadcast address. So I used I use this as a guide, so if you already memorize this number, so it will be easy to you. So I'll just use it for me for us for I'll just use it for a guide, so be my guide in answering the table. So yeah, that's all about the VLSM, or the variable length subnet mask. So it would be easy if you get familiarized. So to get familiar, so just do it and do it and do it again. So and yeah, that's all about the activities here in chapter 8. So thanks for watching, till next time.